Okay, moving on to example B. Again, to do our algebraic juggling, we're trying to see how many times the denominator divides into the numerator. So we start off by saying, what can I multiply the denominator by to get the first term, which is x cubed? Well, we've already got an x squared in the denominator, so if I multiply that by x, then I'll get my x cubed term. So let's write that down. X times my denominator of x squared plus 1. And remember, we're trying to keep the equation balanced, so I divide through in my denominator. Okay, so if I double check, that gives me x cubed, which I'm looking for, so we can tick that off. It also gives me an extra x term, but we're not at that stage yet. We're only going to move on to the x squareds next, so we'll put a wee pin in that for the time being. So I'm then trying to get positive 3x squared. So what can I multiply x squared plus 1 by? Well, the answer is 3. So I'll write that down. Again, to keep it balanced, we divide through by the denominator. Okay, so 3 times the x squared gives me my 3x squared, so we'll tick that off. But it also gives me this extra constant term of 3. Again, I'm going to put a pin in that for the time being because we're not at the constants yet. We're only going to move on to the x terms now. So I say to myself, is there anything I could multiply my denominator by to get 4x? Well, we know straight away that the answer is no, because this 4x is a degree below x squared. Okay, we can't multiply by an x squared to get an x term. It doesn't work. Okay, so we're now finished with using the denominator. So we say, right, I'm trying to get 4x. If I go back to my first pin here, I know that I already had an x term. So how many more would I need to get to 4x? Well, my answer is another 3x. So I'm going to add 3x, but I'm also going to keep it balanced and divide by my denominator. Okay, so that's me got my 4x that I'm looking for. So we'll tick that off. Finally, onto my constant of -5. Again, it's a couple of degrees below this degree of 2 on the denominator because it's a constant, so we cannot use the denominator to help us here. So instead we say, right, have I got anything else here? We've already had x cubed, we've had an x term, we've had 3x squared, but we had this constant of positive 3 here. I want to get down to -5. So if you're already at positive 3, you have to subtract 8 to get to -5. So we're going to put that here, -8, and again, keep it divided by the denominator to keep it balanced. Okay, so now is the easy bit where we can do our cancelling out. So we cancel those two to leave us with x. We can cancel these two to leave us with 3. And then for the two terms at the end, rather than having them over two separate fractions, we can collect them together because they're over the same denominator. So we can put plus 3x minus 8 over x squared plus 1. And that is my final answer. That's me applied algebraic juggling so that I could divide these two terms here, because this had a higher degree than this one, meaning it was an improper rational fraction, and we've now made it proper.